discuss about the inverse trigonometric function. What is an inverse function? Inverse function is the relation formed when the independent variable is exchanged with the dependent variable in a given relation. There are 4 simple steps on how to solve an inverse function. Step number 1, let y equals to f of x. Step number 2, interchange the variable x and y. Step number 3, solve for y in terms of x. And step number 4, replace y by f inverse of x. And lastly, always remember that the inverse of a function may not always be a function.
Hello guys, so before we further discuss about the topic that was assigned to us, our group decided to render a song that is all about inverse trigonometric functions. We hope you like it.
Start it again, check the equation. Every number is a shooting star, trying to get the right solution. Learning in every wrong to make it right. I'll try again, and I will make it right if I try harder than ever.
The equation here is arc sine 1 over square root of 2 is equal to x, which means sine of x is equal to 1 over square root of 2. So now for the next step is to figure out not yet where the sine is 1 over square root of 2, but just where sine is going to be positive, because this is positive 1 over square root of 2. So sine is positive on the top of the Cartesian plane. So it's possible that this is going to be a triangle in the first quadrant or second quadrant. Then we have this chart where we could have easily find where exactly x can be. For inverse sine, for arc sine, it was that x can be between negative 90 degrees and 90 degrees. Okay, so between negative 90 degrees and positive 90 degrees, that is on the right hand side. So the triangle on the left side doesn't matter anymore because it is not on the correct side. So we've seen now that the x has to be in the first quadrant. So the next step was just writing what we've got. So sine of x is equal to 1 over square root of 2. Remember that sine is opposite over hypotenuse. So in this case, the opposite side is 1 and the hypotenuse is square root of 2. If you do the Pythagorean Theorem, or maybe you just recognize this special triangle, then that makes the last side there be is 1. And then we just ask what the triangle has 1 and square root of 2. And it's the 45-90 triangle. So in that case, I can say that x is 45 degrees. Or if you want it in radians, it's pi over 4. We know that the answer we've got for x is between negative 90 degrees and positive 90 degrees. And yes, 45 degrees is definitely between negative 90 degrees and positive 90 degrees. So here we go. We got the answer. X is equal to 45 degrees or pi over 4.
Arctangent negative 1 equals x. Means tangent x equals negative 1, just like my very first step is just checking where is tangent gonna be negative. Tangent negative is in the second quadrant, so the triangle are there. And in the fourth quadrant, so the triangle could be there. And so again, we look at the card and we see that the arctangent x meant to be between negative 90 degrees and positive 90 degrees. So again, that means we're gonna take the triangle on the right there. That one of the left is not between negative 90 degrees and positive 90 degrees. Okay, so let's go ahead and keep going. So again, we write out where tangent is. We know that tangent is opposite over adjacent. So right now, negative 1 is not written as a fraction. In order to use as opposite over adjacent, is just write it as a fraction just to make it look nice. Okay, so now I see the opposite side is 1. And sure, after this is negative 1. And so I'm going down, and the adjacent side is positive 1. And sure enough, it is positive 1 because it's going to the right one. Okay, so now again, we use a Pythagorean Theorem, and you see that this last side is square root of 2. So again, there's a 45, 90 degrees, so that means is the x on the inside is 45 degrees. Okay, now, the one thing you have to be careful is, what is your answer? First step should be going backward 45 degrees, meaning negative 45 degrees, or is the correct answer that I should spin all the way around the other direction, in which case I like to think of it I spin 360 degrees, but I back off 45 degrees, which is the same thing is 315 degrees. So the question is, answer should I give, because for this problem they are not both correct. Only one of these two answer is correct. Is again to think about your card. For arctangent x needs to be between negative 90 degrees and positive 90 degrees. Negative 45 degrees is between negative 90 degrees and positive 90 degrees. However, 315 degrees is not. 315 degrees is bigger than 90 degrees, so I have to throw that one away. So negative 45 degrees is my correct answer.
Okay, let's go to the next one. Arc cos of negative 1 is equal to x, means cos of x is equal to negative 1. So again, we play the same game whereas cos of x is on the left hand side. Either it is on second quadrant or the third quadrant. Okay, so if we look at the chart, our chart says for arc cos, x is between 0 and 180 degrees. So I will discard the triangle on the bottom or the third quadrant because that is bigger than 180 degrees. And we'll just keep going like this and write this as negative 1 over 1. The cosine is adjacent over hypotenuse. So you go ahead and fill that in. You say that the adjacent side is negative 1, the hypotenuse is positive 1. You do the Pythagorean Theorem and you'll get the last side, which is 0. So you just drew a triangle where one of the side is length 0. So what are you supposed to do now? I mean, after all, you certainly don't know any triangles that are 1 is 0, 1 triangle. So this is why people get confused on this. So go and look at this graph. So we see that we are going left negative 1, but we're going up 0. What would it mean to go less negative 1 and go up 0? That means exactly this point right here on the left, right this point. To get there, I move to the left 1. Move negative 1 and the x, and I move up 0. So there we go. We found exactly the point that we care about. How do I get to that point? I spin around 180 degrees, and that is how you can do that from the picture. So if you want to go and draw a triangle, you can see that you have a side of length 0. And then just think about what that means. That means scooting to the left 1 and going up 0. Put a point where that is and then tell me, how do I get to that point? I get to that point by spinning 180 degrees. And here we go. We've done that as well.
Number 4. Arc sine cosine pi over 4 equals x. In the example of number 4, where there are two parts, there's an arc sine and then inside it, there's more stuff, a cosine. So we're going to start the same way they did. So we're gonna write out what this means. Means is that sine of x equals cosine of pi over 4. Remember, you take the sine from arc sine. You jump to the other side to get to x. Then that equals whatever is on the inside. So pi over 4 is the same as 45 degrees, and that in this first quadrant. That gives me triangle 45 to 45 to 90, or pi over 4, pi over 4, pi over 2. The 45 to 45 to 90 triangle has sides 1, 1, root 2. Cosine of pi over 4 is the adjacent side divided by the hypotenuse. So now what I'm doing is the problem sine of x equals 1 over square root of 2. If you go back, you see we did that in problem number 1, and we got the answer of x equals 45 degrees. So there we go, we've done with this one as well. So we've seen when you put more stuff inside, that's not really harder. All we had was this one extra little step of actually computing that cosine of pi over 4 was, but besides that, it was the same as what we've done.
Number 5. Start writing equals x and I write this means. The problem is I was doing that because the thing on the outside was an arc cosine, arc sine, arc tangent, or whatever. In this one, the arc is on the inside and the outside is just plain cosine. The inside is already arc, so what I'm gonna do is to start dealing with that inside dealing with the arc part. So let's go ahead and do that. What I'm going to do is I'm going to go ahead and take this part right here, arctangent 1/3. I'm going to do this one on its own first. This is going to be my step 1. So just like before, I'll go ahead and write out what this means. Means tangent of x is equal to 1/3. Where is tangent positive at tangent is positive in the first quadrant, in the third quadrant. And again, just like the last time, for arctangent, we need x to be between negative 90 degrees and 90 degrees. So I can throw away the triangle on the left, and the tangent is opposite over adjacent. Okay, so now find the hypotenuse. I'll do the Pythagorean Theorem, so my hypotenuse is square root of 10. So you might think you're in trouble here because you have never seen a triangle, let us say 1/3 root. 10 triangle, we just don't know what angle x should be. The important thing is, I don't care about the angle axis. After all, what I am doing is I'm not trying to figure out what is arctangent equal. I'm trying to figure out what is the cosine of arctangent equal. So let's go ahead and look at this again. So I've got a cosine of arctangent of 1/3, and I just said I'm going to call arctangent x. See? Right above I said arctangent is x. So all I'm doing is finding the cosine of x. So just look at your triangle, what is the cosine of x then? Cosine is the adjacent side over the hypotenuse. So it's x equal to 3 over the square root of 10. And there you go, that's how to solve the problem.
In real-life situation, we have an example. It's about the Leaning Tower of Pisa. The Leaning Tower of Pisa is an excellent example to understand the application of inverse trigonometry. It is a remarkable architectural structure from medieval Europe. The tower began to tilt during the construction due to an inadequate foundation on the ground. The tilt increased in the decades, and the rate at which the tower started to lean was such that it would have fallen with time. So, in order to preserve the historical architectural masterpiece, an international team of geotechnicians, engineers, mathematicians, structural engineers, and historians were gathered in an attempt to save the famous landmark. First of all, the angle at which the tower was leaning was calculated. As you can see at the figure, the height of the tower is the hypotenuse, and its distance from the center is the perpendicular. So they have a value of perpendicular and hypotenuse. From the table of geometric ratio, we can see clearly that sin theta is equal to perpendicular upon hypotenuse. Sin theta is equal to 5.45 over 58.36. After we divide it, we can get a value of 0.0933. After that, the value will be multiplied to sin raised to negative 1, and we can get a result of 5.3580 degrees. So sin theta is 5.4 degrees approximately. In this way, they used the concept of inverse trigonometry to find the angle at which the tower was leaning. Therefore, the tower had to be moved by 5.4 degrees to straighten it. But government of the city considered it very important to retain the tilt of the tower, due to the role that this element played in promoting the tourism industry of Pisa. So, it was decided to move the tower a little. The tower was moved by approximately 1.55 meters. As a result, the top of the tower displaced horizontally at 3.9 meters from the center, and the height of the tower reduced at 56.67 meters. So we can see at the figure of the tower, the height is hypotenuse and its distance from the center is perpendicular. So they made a calculation with the values of perpendicular and hypotenuse. From the table of geometric ratio, the sin theta is equal to perpendicular over hypotenuse. So sin theta is equal to 3.9 over 56.67. After we divide it, we can get a value of 0.0688. After that, the value of sin theta will be multiplied by sin raised to negative 1, and we can get a result of 3.94 degrees. So finally, the tower was tilted at an angle of 3.9 degrees and declared safe for the next 300 years.
can check the equation. Every number is a shooting star, trying to get the right solution. Learning in every wrong to make it right. I'll try again, and I will make it right. If I try harder than ever, it never solve every word problems if you solve